The valves feature a robust turning mechanism using a hydraulic actuator system that enables smooth, precise rotation of the massive butterfly discs, ensuring reliable shutoff and flow control under high pressure. The assembly of the DN2000 VAG EKNH 1200 butterfly valves was a complex and meticulous process carried out at VAG's manufacturing facility in Mülheim, Germany. Each valve, due to its massive size and the critical role it plays as a turbine inlet, required careful alignment of all components, including the valve body, disc, and shaft. Precision machining ensured tight tolerances for optimal sealing and performance. The hydraulic actuator and self-closing mechanism were integrated during this phase, followed by rigorous in-house testing. Assembly also involved fitting the valves with specially designed sealing systems to withstand high-pressure operation. Throughout the process, quality control teams monitored every stage to guarantee compliance with safety, performance, and customer-specific requirements before the valves were cleared for transport. Drilling of the disc and shaft for the DN2000 butterfly valves required high-precision CNC machining to ensure exact alignment and dimensional accuracy. The disc, made from high-strength steel, was drilled to accommodate the shaft with minimal tolerance to prevent leakage and ensure structural integrity under pressure. Specialized jigs and fixtures were used to maintain concentricity during the drilling process. The shaft bore was then honed to achieve a smooth surface finish, crucial for proper sealing and long-term durability of the rotating assembly. The integrated dismantling joint was engineered to facilitate easy installation and future maintenance of the DN2000 butterfly valves. Positioned adjacent to the valve body, it allows axial movement by providing adjustable length, enabling technicians to insert or remove the valve without displacing connected pipe sections. Manufactured from high-strength materials, it is designed to withstand high internal pressures and external loads. The joint includes sealing elements and tie rods to maintain leak-proof performance while absorbing pipeline stresses during operation and disassembly. The VAG HYSEC assembly is a high-performance safety and control system integrated into the butterfly valves. It ensures reliable, automatic valve operation under varying pressure conditions. The assembly includes advanced sensors, actuators, and control units, which enable real-time monitoring and precise valve adjustments. Designed for safety, the HYSEC system features self-closing capabilities in emergencies, preventing potential damage or system failure. The system is fully tested to meet stringent operational and safety standards. The disassembly of the old valves involved carefully removing them from the valve house, utilizing specialized tools to detach them from the pipeline. Precautions were taken to avoid damage during the process. The installation of the new valves involved precise positioning and alignment within the valve house, ensuring proper connection to the existing pipeline. Special tools and lifting equipment were used to handle the heavy DN2000 valves. Once in place, the valves were securely bolted, and pressure tests were conducted to confirm functionality and sealing. Installing the supporting mesh involves attaching steel wire mesh to the tunnel walls using bolts or nails. This mesh stabilizes loose rock and provides a foundation for subsequent shotcrete application. Shotcrete is applied using high-pressure hoses that spray a concrete mixture directly onto the tunnel walls. This layer adheres to the rock in the supporting mesh, providing immediate structural support. It helps prevent rock falls, seals small cracks, and forms a smooth surface, preparing the area for further excavation and reinforcement. Holes for securing anchors are drilled into the tunnel walls at precise angles and depths using pneumatic or hydraulic drills. These holes are designed to accommodate rock bolts that reinforce unstable rock. Securing anchors, typically steel rock bolts, are inserted into the pre-drilled holes to stabilize the tunnel walls. Once in place, they are tensioned or grouted to bind fractured rock layers together. This reinforcement helps distribute stress evenly, preventing collapses and enhancing the overall structural integrity of the tunnel during and after excavation. Blasting holes are drilled in a specific pattern and depth using heavy-duty drilling equipment. These holes are strategically placed based on geological analysis to ensure optimal rock fragmentation. Precision in their placement is crucial, as it determines the effectiveness of the blast, minimizes overbreak, and ensures the safety of both workers and structures. Preparing for the blast involves clearing the area of all non-essential personnel and equipment, securing the site, and conducting final safety inspections. Protective barriers may be installed, and all systems are checked to ensure proper detonation sequencing. This careful preparation minimizes risk and ensures the blast proceeds safely and effectively. The blasting holes are filled with two component explosives, typically a mixture of emulsion and a sensitizing agent, which are combined on-site for safety. This type of explosive is stable until mixed, reducing the risk of accidental detonation. Once prepared, the mixture is pumped into each hole to ensure even and effective distribution. Once the blasting holes are filled with explosives, the next step is to connect the detonating fuses. These fuses are linked to each charge, ensuring that all explosive charges detonate in the correct sequence. The fuses typically consist of electric or non-electric systems, depending on the tunnel's specific safety requirements and the blasting pattern. Electric detonators are more commonly used, where a triggering signal is sent through wires to initiate the blast. Timing is crucial, as the fuses must be connected to ensure the controlled, sequential detonation of each explosive charge. This sequence maximizes rock fragmentation while minimizing the risk of overbreak or unintended damage to the tunnel structure. The entire setup is carefully inspected to verify that the connections are secure and functioning correctly before the final detonation. Amiblu specializes in providing innovative and reliable solutions for drinking water storage, ensuring the highest standards in quality, durability, and environmental safety. Two of the company's standout projects, Kreiglingen and Lützen, highlight the versatility and performance of Amiblu's multi-chamber GRP, glass-reinforced plastic systems, specifically designed for drinking water infrastructure. The Kreiglingen project features a multi-chamber system equipped with an intermediate valve chamber, allowing for greater control and compartmentalization of water flow. With a nominal diameter of DN3000, this system is built to handle large volumes while maintaining a compact and space-efficient layout. One of the major advantages of this installation is its modular design, which allows for future retrofitting or expansion without the need for significant structural changes. The system is engineered for easy and quick installation, reducing both time and labor costs during implementation. As with all Amiblu solutions, the Kreiglingen system meets all drinking water standards, ensuring safety and regulatory compliance. It also boasts leak-proof pipe connections, providing long-term reliability and minimizing maintenance needs. The Lützen installation showcases a multi-chamber system as well, this time with a transversely installed valve chamber. This configuration offers additional layout flexibility for specific site conditions or engineering requirements. With nominal diameters of DN3270 and DN3000, the system is capable of accommodating various flow capacities. A key feature of the Lützen system is its UV-resistant material, which offers robust protection against sunlight degradation. This makes the system particularly suitable for installations where parts of the infrastructure may be exposed to direct sunlight or harsh environmental conditions over time. Global Hydro, a leader in hydroelectric power solutions, specializes in the production of high-efficiency Francis turbine runners. These runners play a crucial role in hydroelectric power plants, especially where water flow is consistent and the head is moderate. Global Hydro emphasizes sustainability, precision engineering, and state-of-the-art technology throughout its manufacturing process. The process begins with the 3D design of the turbine runner, created using advanced CAD/CAM systems. These tools not only define the geometry of the runner, but also simulate the entire machining process. This simulation helps optimize material removal, prevent collisions, and fine-tune milling paths before production begins. The detailed preparation ensures a seamless transition to the physical manufacturing stage. The raw material for the runner is selected with great care. Global Hydro uses forged high-alloy stainless steel, chosen specifically for its high tensile strength and wear resistance, which are vital for enduring the harsh operating conditions within a turbine. Depending on the complexity of the runner, it may be manufactured from 1 or 2 forged blocks. Once the material is ready, precision milling is performed using a 7-axis CNC machining center. This advanced equipment allows the creation of intricate geometries without the need to reposition the material, enhancing both accuracy and efficiency. Milling can take up to 400 hours, depending on the size and complexity of the runner. After the milling phase, the runner undergoes hand polishing to ensure a smooth surface, which is crucial for optimal hydraulic performance. For runners composed of multiple sections, heat treatment is applied to relieve internal stresses and increase durability. Quality control is integral to every stage. The runners are dynamically balanced to meet ISO 1940 standards and undergo rigorous dimensional inspections using digital measuring tools. Each runner must meet strict tolerances to ensure a perfect fit and high efficiency in operation. Before the final assembly, the turbine components are subjected to pressure testing, following European pressure vessel directives. Spiral casings are filled with water and pressurized to check for leaks and structural integrity. These tests are witnessed by customers during the factory acceptance process. An innovative aspect of Global Hydro's design is the self-resetting guide vane mechanism, which allows the vanes to deflect and reset automatically if foreign objects enter the water flow, ensuring continued operation and minimizing damage. The Kouris Centri turbine, KCT, by KapaLamda is a groundbreaking hydropower innovation designed to harness the kinetic energy of flowing water without the need for large dams or invasive infrastructure. It represents a significant leap in sustainable energy solutions, combining efficiency, simplicity, and environmental sensitivity. In a short documentary-style video, viewers are taken through the journey of the first-ever KCT installation in Europe, completed during the summer of 2014 in Ano Poroia, Saras, Greece. The video begins with the manufacturing process, showing the precision engineering involved in constructing the KCT's unique centrifugal turbine. The system is fabricated from robust, corrosion-resistant materials, and its design allows for energy generation in low-head and slow-flowing water environments. Once manufactured, the turbine is transported to its installation site, an unassuming river in northern Greece. The video captures the assembly and installation process, which is impressively minimal in terms of civil works and ecological disruption. Unlike traditional hydropower systems, the KCT requires no large-scale excavation or alteration of the natural watercourse. The compact unit is mounted securely within the stream, using a custom-designed support structure that directs water flow efficiently through the turbine. The result is a fully functional microhydro unit that begins producing electricity almost immediately after installation. Local technicians monitor and fine-tune the system, ensuring optimal performance. The project in Ano Poroia highlights not just the technical success of the KCT, but also its potential for off-grid communities, rural electrification, and sustainable development. The Water Rotor technology, developed by inventor Fred Ferguson, harnesses energy from slow-moving water to generate electricity. Unlike traditional turbines that require faster flow speeds, the Water Rotor is designed to capture energy from water moving as slowly as 2 to 6 miles per hour. Its innovative blade design features a scoop-shaped front to create high drag and a wing-shaped back for high lift, allowing the rotor to efficiently convert the kinetic energy of water into electrical power. The manufacturing process focuses on producing turbines in various sizes, from small consumer units to larger industrial models, making it versatile for different applications. Extensive testing in rivers and flume tanks has proven the technology's effectiveness, with prototypes converting more than 50% of the available energy into electricity. Environmentally friendly, the Water Rotor allows fish and marine life to pass unharmed, and its portable units can be deployed in off-grid areas. By providing continuous, low-cost energy, Water Rotor offers a sustainable alternative to diesel generators and solar power, offering a reliable power source for remote communities and disaster relief efforts. At Siemens Energy's service center in Mülheim, Germany, the repair and refurbishment of large industrial steam turbines is a highly specialized and meticulously coordinated process. This was exemplified in a recent project involving a severely damaged steam turbine shipped from Israel. The turbine arrived in parts aboard an Antonov AN-124 cargo plane, marking the beginning of a complex, multi-million-euro undertaking. The turbine had suffered a thermal shock due to improper operation. Cooling water was fed into a 450 degrees Celsius rotor, causing severe deformation and a large crack. Recognizing the urgency, Siemens Energy immediately began disassembly and inspection upon arrival. Given the turbine was not originally manufactured by Siemens, no technical drawings or measurements were available. This made it necessary to conduct a comprehensive 3D scan of the rotor and components. These scans enabled engineers to create accurate digital models, which were essential for diagnosing damage and fabricating replacement parts. Next, precision measurements using advanced 3D tactile probes identified a 0.5 mm warp in the rotor and other distortions. A critical phase followed: a heat treatment to relieve stress and correct the rotor's shape. This involved heating the rotor in a vertical position, a procedure that required custom lifting and clamping equipment designed in-house. Several turbine blades were found to be irreparably damaged and were subsequently replaced. Siemens Energy fabricated new blades after measuring the originals and ensuring compatibility with the existing design. The repair also included restoring worn-out rotor surfaces using laser cladding, a welding process that allows precision material buildup without introducing excessive heat stress. After structural repairs, the rotor underwent dynamic balancing. The service center boasts a high-speed balancing facility capable of testing rotors up to 32 tons and 12,000 revolutions per minute. This step ensured the turbine could operate safely and efficiently post-repair. Throughout the project, Siemens maintained close communication with the customer. The client's delegation even visited the site to review progress and inspect the facility, which demonstrated Siemens' commitment to transparency and technical excellence. The entire repair process, from disassembly to final testing, was completed in just 3 months. Horsburgh & Scott has been a leader in industrial gear manufacturing and gearbox refurbishment for over 130 years. With a strong foundation built on engineering excellence and a commitment to innovation, the company has maintained its position at the forefront of the gear industry. Specializing in the design, manufacture, repair, and refurbishment of custom gearing and gearboxes, Horsburgh & Scott serves a wide range of industries including steel, mining, energy, and marine. At the core of Horsburgh & Scott's operations is its gearbox production and refurbishment process. This process begins with precision diagnostics and measurement using advanced tools such as the Ferro-Arm Coordinate Measuring Machine, CMM. This technology enables engineers to capture highly accurate, three-dimensional measurements of gear surfaces and components. These precise measurements are crucial for evaluating wear, identifying failure points, and ensuring that refurbished parts meet strict tolerances and specifications. For new gear production, Horsburgh & Scott employs state-of-the-art gear hobbing and gashing machines. These machines are vital in cutting and shaping the gear teeth on a blank gear component. Recent investments in 2-meter and 3-meter hobbing and gashing machines have significantly improved the company's manufacturing capabilities. These machines are equipped with internal and external gashing heads, which allow for versatile machining processes on large and complex gear parts. Additionally, their modern design enables faster feed and speed rates, up to 16 inches per minute, while maintaining high accuracy and surface quality. In some cases, the company achieves AGMA 9 quality standards using hobbing alone, a level of precision that speaks to the rigidity and performance of the new equipment. What sets Horsburgh & Scott apart is not only its manufacturing prowess, but also its comprehensive gearbox refurbishment services. When a customer's gearbox experiences wear or failure, the company can disassemble, inspect, and rebuild it to like-new condition. The refurbishment process includes replacing worn gear teeth, bearings and seals, remachining surfaces, and, when needed, redesigning components to improve performance or adapt to new operating conditions. The integration of modern technologies into older gear systems often results in improved efficiency and reliability, extending the life of critical equipment and minimizing downtime. Beyond the mechanical work, Horsburgh & Scott places a strong emphasis on quality control throughout every stage of production and repair. Each gearbox and gear component is rigorously inspected and tested to ensure it meets exacting standards. This attention to detail ensures that customers receive robust, high-performance solutions tailored to their specific needs. Horsburgh & Scott exemplifies excellence in industrial gear manufacturing and gearbox refurbishment. Through the use of cutting-edge technologies, expert engineering, and a commitment to quality, the company continues to deliver reliable power transmission solutions that support the most demanding industrial applications. Whether producing new gearing systems or breathing new life into aging gearboxes, Horsburgh & Scott remains a trusted partner for industries around the world.